Welcome to Chemistry Lab. Today's lab, crystal violet, a kinetics study. We're going to be looking at crystal violet, which is a kind of large organic compound, and its reaction with sodium hydroxide. It's a relatively slow reaction. We can watch it over time and determine the kinetics of crystal violet in this reaction. In other words, we're going to be looking to see if it is zero, first, or second order in crystal violet. Here's the structure of crystal violet. You can see that it's a large organic compound, and it is a dye. You'll want to be careful to avoid getting it on your skin. The assistants in lab will be helping you to pour it to make that a little more possible. But the dye, the crystal violet, will fade over time as it reacts with sodium hydroxide. So we can watch the fading of this violet color colorimetrically in a little colorimeter, where we have the relationship between the absorbance of light is equal to some constants times C, which is the concentration in molarity. So the amount of light absorbed is related to the concentration. And so we can gather information about this compound. We can look at what concentration of crystal violet we have at different periods of time, and we'll use the LabQuest colorimeter to collect all of these data points, and then we'll be able to graph them to determine whether the reaction is zero, first, or second order. I'm not going to go into a lot of details regarding exactly how to gather the data. You'll spend there are a lot of written instructions in the lab manual for that, and your instructor will talk to you more about that in lab as well. There is one important point that I want to bring up here. The experimental conditions are on the SD card of the LabQuest device. So the instructions tell you to open the file on the SD card. That's where the experimental conditions are. And if you don't see the SD card and you accidentally use the default conditions, then the experiment is done in 120 seconds and you haven't collected nearly enough data and you have to start over again, which is never a good thing. Nobody wants to start over again. So just make sure that the SD card shows up. If you don't see an SD card, then sometimes those little things become unseated and they just need to be seated back appropriately, or sometimes they are missing. But tell an instructor or one of the assistants in the lab and they'll make sure that you get a device that has an SD card in it. Also, at the start of the lab, you need to move fairly quickly in terms of mixing your solutions and putting them in the colorimeter and collecting and starting to collect data as soon as possible. There's a lot of good information, concentration versus time, that occurs at the very start of the lab that is pretty critical to getting the correct results here. So what I mean by that is when you mix the solutions together, as soon as you get them mixed, get them quickly into the colorimeter and hit go. Once you gather the data, you have it all in the LabQuest probe, you'll be able to analyze that data by graphing it and looking for the best fit straight line to determine whether you have zero, first, or second order kinetics. Remember that when you're talking about zero order kinetics, the equation that describes zero order kinetics is concentration at particular point in time is equal to negative KT plus the initial concentration. This equation is written in the form of a straight line, y equals mx plus b. So when you try to graph the data that you have, you're going to look at concentration versus time. The slope will be negative. If the data you collected gives you a straight line when you put concentration versus time, then you're looking at zero order kinetics. If you're doing this for first order kinetics, the equation is natural log of concentration is equal to negative KT plus natural log of initial concentration. And so when you graph natural log of concentration versus time, and once again a negative slope. If this gives you a straight line, then you're looking at first order kinetics. The last one that you'll be comparing is second order. Begin. For a second order reaction, the equation is 1 over the concentration is equal to KT plus 1 over the initial concentration. The graph, running out of space here, 1 over concentration versus time, positive slope in this case. So you're going to be generating all three of these graphs, and one of the lines will be more straight than the others. You might be able to just look at the lines and say that one of them looks like a straight line and the other two appear to be curved instead of straight. But you can also look at the correlation coefficient for the lines and pick the one that gives you the strongest correlation coefficient. And that should correspond to the kinetics of crystal violet in this reaction. I believe that's all you need. Have a great lab.